Hey folks, welcome to our intro video for Unit 13 on how we're going to be solving literal equations. Now for right now, I'm not going to define what a literal equation is. I'll talk to you about that a little bit later on in the video. But an easy way to kind of think about it for right now is to simply rewrite a certain formula, okay? So in a little bit, I'll come back and talk about what it means to solve a literal equation, but for right now, it's okay to just be thinking of it as rewriting a certain formula, all right? So let's dive on in here with this first example so I can show you guys what I mean. So you guys know that if there's a hypotenuse given, that we can label that on the shape. So here we have a triangle that has a hypotenuse as 12.5, and one of the leg measures 10 inches, and this would be the right angle. And what we're going to try to do here is find the other leg, which is going to be this blue side down here, all right? Now, friendly reminder for the Pythagorean theorem that the A and B are both your legs, and it doesn't matter which one is which. For the sake of simplicity, I just said that this one's going to be A and then this is B. So I've got that. We have 10 squared here. We know the hypotenuse is over here. That's C squared. And what we're trying to find right here is going to be the missing side length B. All right, so we have 10 squared plus our unknown side squared equals 12.5 squared. Now we care that the 10 squared is 100, and we care that 12.5 times 12.5 is this 156.25. Now to solve for a missing leg, we basically take the hypotenuse squared and we just subtract what the other leg squared is. So I'm going to subtract right here, and I'm going to have 56.25 left on this side. So B squared is 56.25. Okay? You might remember from this unit that now what we have to do is take the square root of this number. And when I get the square root of the 56.25, because we have to subtract the 100, so square root of this is going to be a 7.5, okay? So this side length right here would be a 7.5. And now let's take a look at another example. In this example, we have that side length A is 12, so I'll let this be a 12. We have side length C, the hypotenuse here is a 20. So we're trying to once again find this bottom side. Now, if we follow what we did here, you guys know that basically we're going to do this thing squared and then minus this thing squared, and then we just need to take the square root of that answer. So again, what I just said is we're going to have the 20 squared. We're going to be subtracting whatever 12 squared is. It's the exact same thing we did right here. So you've got your hypotenuse squared, and you're just subtracting the other leg squared. So this would be a 400. This is a 144, and when I subtract them, I get a 256. Now, when I take the square root of 256, we get a 16. So we know this side length here is a 16. Now, if I say we're going to now solve a literal equation, aka rewrite the Pythagorean theorem, here's what we're doing, y'all. We have the Pythagorean theorem here, a squared plus b squared equals c squared. And what we're trying to do is basically solve it for b, which is what we just did in these two problems. We used the Pythagorean theorem and we solved it to find the missing length of the right triangle. So to do that, what we did was we had a squared, we plugged it in, and we had a c squared plugged in. And what we did was we essentially subtracted a squared from both sides. Now, up here in both of our examples, I had numbers to actually subtract, like I did the 156.25 minus the 100. And here I did the 400 minus 144. But when we're solving a literal equation, we're trying to just do this without any numbers. So I don't have a c squared and an a squared to actually subtract, but I know a squared minus a squared cancels out over here. And then I have that b squared would be left on this side. And over here, the number that I would have is whatever c squared minus a squared is. And then the next step we did in both examples was to get b all by itself. Now we took the square root when we subtracted these numbers. So to find b, I'm going to now take the square root of whatever this difference is. So if I'm rewriting this equation here for b, it's b equals whatever c squared minus a squared was, and then we take the square root of it. This is you rewriting the Pythagorean theorem to find what b would be. And that means you've just now solved a literal equation. And for it to be a literal equation, it's just going to be all of what you're used to with like letters and numbers. And instead of trying to solve it to get an actual answer, you're just going to be rewriting it for whatever letter I tell you to rewrite the letter for. Okay? So this is your first example, and now I can show you the reason we care about doing something like this is if I had asked you another question where it's like, all right, you have one of the legs and you have the hypotenuse, what is the missing leg? Instead of having to do all of this crap like you've done all school year, you now have a formula for how to find the missing leg. And all you would do is say, okay, I've got c squared, so I would do 26 squared. I'm going to subtract whatever 10 squared is, and then I'm going to take the square root of that answer. Now, 26 times 26 is 676. 100. 10 squared is 100, so I'm going to subtract 100. I'm eventually going to take the square root of that difference. So we're eventually going to take the square root here of 576. And when I take the square root of 576, we get a 24. So the side length here that was missing was a 24. So that is the goal of this entire unit, is to learn how to take something that I've given you and to rewrite it for another one of the letters. We have another formula from this school year, the simple interest formula, where I can actually show you again the annoying problems you had to do. And if you actually have this skill of rewriting an equation for a certain letter, these type of problems become much easier. All right, so let's go back to the I equals PRT formula that you guys know. And it always looked like this, I equals PRT. And there were problems this school year when I wanted to know what is the interest rate. So in this scenario, Daniel invested $2,500. So we have our principal is $2,500. And he invested this for 18 months. Now 18 months is 1.5 years. So I'm going to put a 1.5 here for years for time. If it earned $71.25 in interest, so that means over here we have the $71.25 that it earned. And we're trying to find the red number here, the interest rate. Now to do this, what you guys did this school year was you simply multiplied the 2,500 times the 1.5, and then you just simply divide both sides by this answer. So what I'm going to do in the calculator is do 2,500 times 1.5, so 2,500 times the 1.5, and that was 3750. So I'm going to divide both sides here by the 3750. And when we divide by the 3750, we'll get the decimal in the calculator for the interest rate. So the interest was 71.25 divided by the 3750. And here, when I move this decimal over, I'm going to get a 1.9%. So here R was 0.019. And when I move that over twice, we get a 1.9% for this answer. All right. So these were the annoying types of problems where I gave you P, T, and the interest earned, and you had to solve for the rate right there in the middle. And to do that, we just divided this number over here by the product of P times T, which was 3750. Let's see it again one more time. We're going to find the interest rate for an investment of 1,500. So this time, 1,500 is the principal. We do not know R. And it was in there for 1 year, so this is just a times 1. It earned 54 in interest. So what we're going to do is we're going to divide both sides by 1,500 times 1, which in this case is just a 1,500. So really we just need the calculator to do the 54 divided by 1,500. So this part is hopefully not new. 54 divided by the 1,500. And when I move that decimal over twice, I'm going to get a 3.6%. So 3.6% for this one. So what we're doing to solve for R is we're basically just taking the interest and we're dividing it by whatever P times T is. We did it here. We took the interest and divided it by P times T. So let's look then at the literal equation. If I have the simple interest formula and every time I'm trying to solve it here for R, I'm actually just going to divide by whatever P times T is. Now, when you're solving the literal equation, like I said, it's back to just being all letters. There's no numbers in there. So that's what the literal equation is. It's what the formula is and now how to rewrite it for another letter. Now, when I do this, the P and the T would cancel out and the R is all by itself over here. Just like right here, the 2,500 times 1.5, that cancels out right there with the 3,750. Now on this side, To find the rate, like I keep mentioning, it's whatever the interest divided by P times T is. So this right here, we have now completed the problem. We have solved the formula for R. It's the interest divided by PT. So that is what solving a literal equation is, y'all. It is rewriting it for a different letter. And now that you have this formula, it's like, all right, if something earned 250 in simple interest, I've got the 250 as the simple interest up top. I'm going to divide it by whatever the product is of the 4,800 and then times the 2.5 years for this next example. We have 250 interest was earned if 4,800 was invested for 2.5 years. So again, my point is if you have the skill of rewriting and shuffling the letters around, now you can just use a calculator to say, okay, let me get my denominator, 4,800 times 2.5. All right, 12,000. So it's the 250 divided by the 12,000. And here, when we move this decimal over, that would be a 2% interest rate. So the rate here, this was a 0.02, which is a 2% interest rate. So that's the ultimate goal here, is to be able to take a formula and rewrite it for another letter that you might need. All right, we're going to do a couple more here now for just some measurement formulas. So now I can rewrite any formula for a given dimension. We started first with Pythagorean theorem, and then we talked about simple interest, but now we're going to be looking at pretty much any formula that I give you and how to rewrite it. All right, now stick with me on this. We're going to go with some mental math. We're going to do this one in our head, all right? I want to know how long is the base of this triangle if the area is 30 square inches. Now, you guys might remember that for formula of area of a triangle, it is going to be half the base times the height. So half of my number times 10 is a 30. Half of my number times 10 would be a 30. Now, if we know half of this is times 10 is the 30, I think the first thing most of your brains are going to do is whatever 30 times 2 is to get a 60, and then say, okay, what times 10 would give me a 60? So my base down here has to be a 6, because 6 times 10 is 60, and then I'd cut it in half and I'd get a 30. All right, so we just did that in our heads to find the 6. All right, now same concept over here. The triangle just looks a little bit different. How long is this part? If this times this cut in half gives me an area of 24. So this times this cut in half was an area of 24. So if I didn't cut it in half, I'm trying to make it a 48. And then it's like, all right, well, what number times the 8 would give me a 48? So this right here has to be also a 6. Because 6 times 8 is 48. And then when I cut that answer in half, I'd get a 24. All right, so we just found the answers here. They both happen to be a 6. I didn't do that on purpose. That just happened to be the case. And so what we did to get that was we basically took the area and we simply doubled it. Okay, I did this, doubled and got a 60, and then I divided by my height. I did this, doubled, and then divided by my height. So if I'm trying to always find the base of a triangle, here's how we solve this literal equation right here. I'm going to rewrite it in blue. If this is our formula for area of a triangle, if I'm trying to solve for this letter right here, B, first thing I'm going to do is actually get rid of this fraction, and I'm going to multiply both sides by the reciprocal, which is 2 over 1. When I have the 2 over 1 on this side, it's going to cancel out my half, and basically now we're just saying that the base times the height is whatever the double of the area is. And what that means is I'm saying that the 6 times 10 would have been a 60, or that the 6 times 8 would have been a 48. All right, then what we did is we divided it by the height. We divide by the height, and that cancels out. So now that we have the base is whatever twice the area was divided by the height. That holds up because I could just do twice the area, 60, divide by 10. That's how I got this. I did twice the area here and got the 48, and then divided by the 8, and I got this. So when we're trying to solve for a certain letter, you basically take the same steps that you're used to. In terms of like here, if this is a 1/2, you multiply both sides by the reciprocal. It's just there's no A here to actually get any math answer with. So you're just telling me whatever twice the area is divided by the height is going to be how I find the base. Now you guys are going to realize here that when I cancel this out, this is the answer. And it does feel silly to have to come over here off to the side and say, okay, I've got twice the area divided by height. It does feel silly to have to do that when it's all right here. So you could put that the b equals right here and just circle the answer like that instead of having to rewrite it. And as we do more and more and more of these examples, you'll totally see what I mean about not wanting to have to like rewrite the final answer over here and to just kind of circle what you've done. All right, now that makes a problem like this much easier where it's like, all right, so what's the base of a triangle whose area is 75 and the height is 15? All right, so all I'm going to do then is come through and say, all right, I've got twice my area, so twice the 75, and I'm going to divide that 150 by the height of 15. So 150 divided by 15, I just found the base here, would be at 10 inches. And that's, again, how easy it can be if you know how to rewrite the formula. All right. We're going to do one more here with a formula, and this is going to be how we find the formula for circle, area of a circle, and how we can find any radius ever if we are given the area. Now I'll show you guys again how you've done it in the past this school year. If I want to know what's the radius of this circle, if the area is 78.5, you're basically like, all right, I have the area, which is 78.5, and I know I get that by doing pi times radius squared. So we can divide both sides by pi. And when I divide 78.5 by pi, this is a 25. Let me erase this arrow real quick. Thank you. All right, so I've got a 25 on this side. So all I'm doing is dividing the area by pi. And then I know that I have r squared. So to get r, I just need to take the square root. So what I'm going to do here then is I'm going to divide this by pi. And I'm going to divide this side by pi. And pi will cancel out, and my radius squared will be whatever the answer is to a divided by pi. All right, then I need to take the square root of the area divided by pi. So like I said, that right there would be r, and it's easy to just go ahead and circle the answer instead of having to rewrite it off to the side to say, oh yeah, it's area divided by pi, and then I'm going to take the square root of that, and then I have the radius. It's silly to me to have to rewrite it, so if you just want to kind of circle your answer as you do the math right here, that's fine. And then we can see that that would have worked right here. Let me go back to saying, okay, so like this one has just like a long number, the 122.65625. That's the area, and I know I get that by doing pi r squared. So again, if I just divide the area by pi, that will give me the radius squared. And that's what I'm saying right here. And then when we get an answer, let's do the 122. This one's going to be a little bit longer. 122.65, sorry, 65625. I missed the 2 right here. We're going to divide it by pi. And that is a 39.0625. So 39.0625 is r squared. So now I'm just going to take the square root of this. So I'm going to take the square root of the answer that I got here, and I will have r. So when I take the square root of this, I get a 6.25. So we know the radius is a 6.25. So we can come back through and label here. We have this radius as a 6.25. We just found that one. And I can come through here and label this one. The radius would be here for this one. We said it was a 5. All right. So the beauty of being able to rewrite this is to just say, all right, so now that I know that skill, if it's asking, hey, what's the radius of a circle if the area is 314? All right, so we're just going to take the square root of the area divided by pi. That's what this says. So the area divided by pi, and we're just going to take the square root of that, and we'll have our radius. All right, so 314, that was the total area. Just dividing it by pi. And I get 100. And when I take the square root of 100, our radius must have been a 10. Okay? So I wanted to start with some formulas that I think you guys had some background knowledge on to kind of realize that like we've done the math before, but the math can get a lot easier if we know how to rewrite the equation. And knowing how to rewrite the equation means you are solving a literal equation. So let's flip over here and just see some more examples. We're going to just basically go through this page now, and I'm going to show you guys just the ropes of how it all works, and then you're going to try some on your own. All right. So for this one right here, if I'm trying to solve, this is the formula for area of a trapezoid, and I want to solve it for this thing right here, which is B1. So to get this all by itself, I need to undo everything else. And to undo a fraction, I need to multiply both sides by the reciprocal. I'm going to start to just show a 2a because I think you guys are smart enough to see that. And when I multiply both sides by 2, that cancels this out. So now I just have the h and then parentheses b1 plus b2. Now, if I'm trying to get something in here all alone, I'm actually going to divide by h because h divided by h will cancel out. So then I've got on this side, I've got a divide by h. Okay. So this is the part that I was saying kind of seems annoying and silly about the rewriting, because right now we have that b1 plus b2 equals this stuff right here. But I actually just have to rewrite the problem real quick. I've got that the 2a divided by h, that is now whatever b1 plus b2 is. And if I'm trying to solve for b1, I now just need to subtract b2 from both sides. b1 and b2, you might remember, stand for the bases of a trapezoid. And I know this looks scary right here, but all I'm saying is that if we did 2a divided by h and then subtract whatever the other base was, we would have found one of the bases in a trapezoid. And that would be the final answer. Okay. Now, I always get this from students very early on. Students seem concerned, and I get, huh, what? I don't get it. As we keep going through more examples, I promise this will start to make more sense, okay? All right, so now I'm going to move on to the next one here. So there's a surface area formula, and it's pi RL plus pi r squared, and I want to solve it here for the letter L. Now, this whole term has a plus pi r squared. So if I subtract pi r squared from pi r squared, it will cancel out. And I'm going to also subtract it on this side. But I don't have any numbers here to subtract a number minus a number. So the best I can do is say whatever that surface area is minus pi r squared. That is what the number would be over here. And then this cancels out, and then I've got pi RL. So again, we're trying to solve for L all by itself. So I can actually divide by pi and r. And when I divide by pi and r, that's going to cancel out over here, and L is all alone. So now I'm just going to divide this side by pi r. And like I said, I don't want you to have to rewrite all that. So it is okay to now say, okay, I have solved for L. And now I'm going to box this answer. Okay. The pi and the r's canceled out, and L is all by itself. And I'm just saying L equals, and that's what we found L to equal. All right, here for this next example, if we have that the total volume of something is found by taking a third of pi r squared h, and I want to solve for r, first thing I'm going to do is get rid of this fraction by multiplying both sides by a 3/1. And when I multiply both sides by a 3/1, I'm just going to go ahead and put 3v equals, and 3/1 would cancel out my 1/3. If I had a 3/1 right here, that would cancel out. So I've just got pi r squared left over on this side. Now, if I'm trying to solve, oh, and h, sorry, I can't forget about h. Now, if I want to solve for r, I got to get rid of the pi and the h, so I'm going to divide both sides by whatever pi times h is. Now, this will cancel out, pi will cancel out with pi, and h divided by h cancels out. So now what I have, y'all, I'm just going to write the r squared on this side so I don't have to copy myself down. I now have that r squared equals 3v divided by pi h. R squared, I just wrote it over here. Now, if I want r to be all by itself, I need to take the square root. And when I take the square root of 3v divided by pi h, r is all by itself. So I'm going to just erase this right here. And I'm just going to put the letter r. And we have solved for the letter r when we were given the volume formula for volume of a cone. Okay, so if I gave you a cone and I told you what its volume was, and I told you what its height was, and I wanted to know what the radius right here would be, you would just take 3 times the volume, you would divide that by pi times height, and when you get the square root, you would have found the radius. All right, we're going to keep practicing with this. Now for this one, our goal is to solve the area of a circle formula for pi. So if pi is right here, it's a coefficient of r squared. So if I just divide by r squared and divide by r squared divided by r squared cancels out, and pi is all alone. And so I'll get that by doing a over r squared. So to solve for pi, it's the area of a circle divided by the radius squared. All right, we're done with that one. Now you can see here we still have several more examples, and just pause the video if you need to take a break, but I'm going to keep plowing through here. Now these little numbers, again, they just label something. So like this is the first x, this is the second x, kind of like this is the first base and this is the second base. So this is a formula you guys are going to see next year in algebra. And it doesn't matter what it's for. I'll let the algebra teachers next year do their thing. But the point is I'm trying to solve it for this thing right here. Now this whole denominator is standing in a way. So what I'm going to do is I'm actually going to multiply both sides by the y1 minus y2. When I multiply, just kind of like if you had like a 5 equals x divided by 3, to solve for this thing, to get the numerator alone, you're going to multiply both sides by the denominator. So for this, I'm going to multiply the m times the denominator y1 minus y2. I have multiplied this side by the denominator. This side, when I multiply it, kind of like here, if I did a times 3, it would just cancel out. So now I'm left with the top part, the x1 minus x2. Now, if I'm just saying x here minus something else, what I can do is now put a plus. I could just add this one to both sides. And like I said, it looks weird when it's like vertical like this, but you can see there that that would cancel out. And now let me just rewrite it off to the side so that you guys could see what the final answer should look like here. We've got this is all by itself, so I know what it equals. It equals the purple thing, the m, and then the times y1 minus y2. It equaled that plus x sub 2. So the x sub 1 equals m, and then parentheses y1 minus y2, and then we add the x sub 2. That's this thing plus the x sub 2, and that is our final answer. I feel like this looks a little bit weird. It's kind of sloppy, and it's going to bother me. It might not bother you, but it did bother me. So let me fix that real quick for my folks that might annoy. It was the m, y1 minus y2. And then we simply added the x2. And that was it. Okay? So I'll highlight that one so that it stands out. That's that answer. All right, hopefully we're getting the hang here when we see a fraction, that if you see the fraction, your first step is to multiply by the reciprocal. So I'm going to go ahead and let this be a 3v. And I know that the pi r squared and then the h is left alone. Now earlier we saw a similar example up here and we solved for r, but this time we're going to solve it for h. This is actually going to be a little bit easier because h has all this stuff being multiplied in front of it. So if I just divide by pi r squared, this will cancel out and this will cancel out, and h is all alone. So h is the 3v divided by pi r squared. So the 3v, and then I divided it by pi r squared. All right, so some more examples down here. If we had the area is a half base times height and we're solving it for h, I got to get rid of this half. So I'm going to do a 2a equals bh. And then I would simply just divide by b, and I would divide by b. And now h is all by itself. And like I said, I don't want you to have to rewrite all this stuff, so you can just tell me that the height would be twice the area divided by base, and you can just box your answer like that. All right, now for this one, if we're trying to solve for the letter p, I've got the surface area. And what I'm going to do is I'm going to minus b from both sides. And that's going to cancel out. And on this side, the best I can do is say surface area minus base. And over here, I'd have half LP left over. Now to get rid of the 1/2, I'm going to multiply both sides by 2. So this side, I'm going to use parentheses and say that whole thing times 2. And then over here, I have LP. Now, if I'm trying to solve it for perimeter, I can divide by L, and that'll cancel out. And now I have P all by itself. So I just need to divide this side by L. And like I said, I'm not trying to have to rewrite all this crap, so I can just put the P equals over here, and we are done. All right, only 4 more examples here. And like I said, just feel free to pause whenever you need to take a break. All right, so we've already seen simple interest, and we already know how to solve for R. We just divide this by PT. But if I'm trying to solve it for T, now I'm just going to divide it by PR, because those will cancel out. And so I divided by PR, that is T. And I'm just going to write for T right here. Again, that cancels out, and P is all by itself, and it's I divided by PR. Okay, so for this one, we've got the perimeter of a rectangle formula, and we're just trying to solve it for the length. So if you're ever trying to solve for the length and I've given you the perimeter, what you're going to do is you're going to subtract the 2W. And so here I've just got whatever P minus 2W is. And over here, this is going to cancel out. So I'm left with the 2L. Now trying to solve for L, I'm just going to divide by the 2 and divide by the 2. This is going to cancel out. And so the length here would be whatever the perimeter is minus the other 2 sides, and then just cut that in half. And I'll show you guys, think about this. This makes so much sense. Let's say this was a 10, and let's say this was a 3. You guys know the perimeter is basically 10 plus 3 plus 10 plus 3. So that's going to be a perimeter of 26. Now let's say you did not know that this was a 10. Okay? So what you would do is you would take this 26 right here, and you would subtract twice this width. So you're going to subtract that and tell me that that's minus 6. So what's left over is a 20. And now you're going to cut that in half because there's this side and this side. And that's what we did right here. You cut it in half, and now you solve for the length. All right, just 2 more examples. All right, so C equals 3/4 Y plus B. Now, I know I kept saying when there was a fraction that you deal with it first, but that was when it was all just one big term. Notice that that's what happened here and here. But when we had the 1/2 and then the LP plus B, I took care of the constant first. So I need to take care of the constant first here. I'm going to subtract B. And we know, again, there's no number to subtract B. So what I'm going to do is I'm just going to say it would be whatever C minus B is. And that would equal 3/4 Y. And now to get Y all by itself, I'm going to multiply both sides by the reciprocal of 4/3. So this side has a 4/3 times the C minus B. Whatever the C minus B answer is, it'd be times 4/3. And then again, seeing a 4/3 on this side, you guys know that that cancels out. And Y is all by itself. So we just solved it for Y. We've got 4/3 C minus B. And now for this one, if we're trying to solve it for X, we've got a 4X plus B equals 2X plus C. So you guys know when there's X's on both sides, you go after the smaller one. So that strategy still applies here. And here, if I have 4X's minus 2X's, that's going to be 2X's. Then I have plus B on this side, and then equals C. Now, if I'm trying to solve for X, I got to get rid of B. And similarly, as to the problem right before it, when we don't have the numbers for C and B, I can't really subtract. The best I can do is say whatever C minus B is the answer over here. And then I'm going to bring down my 2X. Now I'm going to divide by 2 and divide by 2. And X is all by itself. And like I said, instead of having to rewrite the C minus B over 2, you could just put X equals right here. And we have solved for the letter X. Now this is a tough unit. Obviously, you guys can see that this is going to be a little bit tricky, but this is a unit that the algebra teachers have asked me to kind of pre-teach to you guys because it is going to be more difficult next school year. So that concludes this video where I'm kind of introing the concept. And what you're going to do now is you're going to try these on your own. And we're actually going to be going over these in class. There's not going to be a Google form. I don't want you guys to worry about how to type in all these weird formatted answers. But that concludes this video, and try these now for practice on your own. Thank you for watching.